Okay, another mode is depletion. In this case, we are putting a positive voltage on the metal, so we're building up positive charges at the metal oxide interface. That creates this band bending, so it creates that space charge region. So this is where we have some charge as well, so that corresponds to some charge building up at the semiconductor oxide interface. If we then vary the voltage that we have across the MOS capacitor by a little bit, we'll change the charge on the metal, and we'll change the width of the depletion region, and therefore change the amount of charge that we have in that space charge region. Okay, so I still have my oxide capacitance, the capacitance associated with this oxide, but I also have a capacitance associated with my space charge region as well, and those are going to be in series. Maybe I'll draw it on this diagram. So my oxide capacitance, and I'm going to have some capacitance associated with the space charge region. Your book calls this C sub SD prime, and those are in series. Okay, so if I have two capacitors in series and I want to figure out the total capacitance, I use this equation. So here's my oxide capacitance, here's my space charge region capacitance, or I can rewrite this equation this way, and then I can say, well, I already know what the oxide capacitance is, and that's the of course, this capacitance per unit area, so the permittivity divided by the thickness of the oxide. And same kind of thing for the space charge region, permittivity, but this is permittivity of the semiconductor, and separation of the charge is going to be the width of the depletion region. Okay, so I'll plug these two back into this equation, and I can get an equation for the capacitance of the MOS capacitor in depletion.